Hello, Math 7 students. We're going to go ahead and start reviewing some of our equations, both 1 and 2 step that we started in December. First, a few reminders. When solving an equation, our goal is to get the variable alone. And remember that the variable is the letter. So whether it's X or Z, etc. We do this, we get the variable alone by using inverse or opposite operations. And remember, whatever we do on one side, we have to do to the other side. It's an equation, so we have to keep it balanced. Remember to check your answer at the end. So inverse operations, we have addition, and its inverse is subtraction. And again, multiplications, inverse is division. So I could go the opposite way as well. Subtraction's inverse or opposite operation would be addition, and division's inverse or opposite operation would be multiplication. We're going to start out by doing two one-step equations together. So as a reminder, when I have my equation, I want to get x by itself. I draw the line underneath the equal sign, so I remember that what I do on one side of the equal sign, I have to do on the other. So if I want to get x by itself, there's a positive 3.2 with the x. So ask yourself, what's the inverse or opposite of a positive 3.2? Hopefully you were able to determine that it would be a negative 3.2. So I'm going to take 3.2 away from this side, and again, if I take 3.2 away from one side, I have to do it on the other. I should see mirror images on either side. So then I've got a positive 3.2 and a negative 3.2. Those two will cancel out because they equal 0. And that leaves me with x equals, and I'm going to compute this side. This side says negative 4.7 minus 3.2, and that equals negative 7.9. Now it's very important to do the check. So I see that x equals negative 7.9. I'm going to plug it back in for x. So negative 7.9 plus 3.2, and it should equal negative 4.7. So let's try it out. Negative 7.9 plus 3.2. What do you get? We should get negative 4.7 equals negative 4.7. Now, if they did not equal each other, then I would know that I did something wrong, and I'd have to try it again. Alrighty, next example, we've got x divided by negative 3 equals 12. So I see that I have some division here. What's the opposite of division? Good, it's multiplication. So I'm going to multiply this side by my denominator. I'm going to multiply this side by negative 3, and I'm going to multiply this side by negative 3, because what I do on one side, I have to do on the other. Negative 3 and negative 3, they're going to cancel out. So all I'm left with is x on the left side equals, and then I'm going to simplify. 12 times negative 3 is negative 36. Now, if I want to check, I'm going to plug in negative 36 where I see that x. So I've got negative 36 divided by negative 3, and it should equal 12. So go ahead and double check. What is negative 36 divided by negative 3? You should get 12, so that 12 equals 12. Again, if we're not getting 12 here, if we got a negative 12 and 12 are not the same number. So we'd want to go back and check our work. All right, you're going to go ahead and try this one-step equation. I will remind you that we have a j minus negative 1. Remember that 2 negatives simplify to 1 positive. So I would rewrite this equation first. Now that you've solved it, let's just make sure we're all on the same track. J minus a negative, these two negatives again, simplify to 1 positive. So I've got j plus 1 equals 7. If I go ahead and solve it, I'm going to draw my line at the equal sign, and then I see that I have a plus 1. The opposite of plus 1 would be minus 1. I should see that on both sides of your work. Now I'm going to simplify each side. 1 minus 1, that cancels out. We're left with j equals 7 minus 1, which is 6. All right, let's move on to two-step equations. Okay, so I see that I have something that's with my variable, but also another number, okay? So that's why it's our two-step equations. This one you could rewrite first, or you could start solving it. I'm gonna rewrite it first. So I'm gonna take all of this and switch it with the 14. Okay, so negative 2y plus 6 equals 14. So it's still the same equation. I just have the y on the right side, left side, excuse me. Sometimes it just makes things a little bit easier for me. I'm going to draw my line and I'm going to box my negative 2y because I'm not going to do anything with negative 2 and y until I get rid of the other stuff that's on the side. So ask yourself, how am I going to get rid of a plus 6? So the opposite of an adding 6 is a subtracting 6. So I'm going to take away 6 from both sides. Plus 6 and minus 6, you know what? They cancel out. So all I have left on the left side is negative 2y equals, and then I'm going to do 14 minus 6. 14 minus 6 gives me 8. And now I am not done. I have a one-step equation left. So I've got negative 2y equals 8. Negative 2 and y are multiplying. When they're smushed next to each other like this with no sign in between, they're multiplying. So the opposite of multiplying would be to divide. I'm going to divide this side and I'm going to divide this side. I'm going to divide by what's ever with y. So I divide by negative 2 on this side and negative 2 on this side. The reason why we do that is because negative 2 divided by negative 2 cancels out. I'm left with y equals 8 divided by negative 2. And 8 divided by negative 2 is negative 4. When I want to go check, I've got negative 2, and instead of y, I'm going to plug in what I got for y, so negative 4 plus 6 equals, I should get 14. Okay, now I'm going to simplify using GEMDAS. So negative 2 times negative 4, 8. Bring my plus 6 down. 8 plus 16, or 8 plus 6, excuse me, is 14. So 14 equals 14. It checks out. Alrighty, one more example of a two-step equation that we'll do together. I've got n divided by 4 minus 16 equals negative 9. I'm going to draw my line so I remember what I do on one side, I'm going to do on the other, and I'm going to box my n over 4. I need to get rid of this part first, this minus 16. So how am I going to get rid of a minus 16? Well, use the opposite. So the opposite of a minus 16 would be a plus 16. If I do it on one side, I'm also going to have to do it on the other. Negative 16 plus 16, that equals 0. Get that out of there. Bring down our n over 4 equals, and then we compute negative 9 plus 16. Don't add any other integer signs in there. And I should get 7. Now what's my next step? I see that n and 4 are dividing. What's the next step? Good, it would be to multiply by 4 on both sides. So 4 and 4 cancel out. I've got n equals, and then 7 times 4. 7 times 4 is 28. Alrighty, so now we're going to go ahead and check our answer. We're going to plug in 28 for n. So I'm going to have 28 over 4 minus 16. And hopefully that's going to give us 9, negative 9. So 28 divided by 4 is 7. Bring down my negative 16. And what is 7 minus 16? It indeed is negative 9. So I know I got that answer correct when I checked my work. Alrighty, we got 2 more for you to try. Okay, so go ahead and attempt this one. So if you've solved this one, you should have subtracted 11 first. 5 minus 11 is negative 6. And I get negative 3x on the other side because 11 and negative 11 cancel out. Negative 3 and x are multiplying, so to undo the multiplication, I'm going to divide by negative 3 on both sides because negative 3 and x are multiplying. Negative 3 divided by negative 3 cancels out. I have x equals, and negative 6 divided by negative 3 is 2. If you need to pause the video and look at that work again, you certainly can do that. The last one that you're going to do is right here. Alrighty, so if I solve this one, I'm going to try to get rid of the plus 4 first. The opposite of a plus 4 would be a minus 4. 4 minus 4 cancels out. I'm going to bring this down. Y over negative 2, and 23 minus 4 is 19. Finally, last step, I see y and negative 2 are dividing, so I'm going to multiply to do the opposite. Negative 2 and negative 2 cancel out. I'm left with y equals negative 38, because 19 times negative 2 is negative 38. Then I would definitely go back and check negative 38 divided by negative 2 plus 4. All right, thank you guys.